Welcome to LabMinutes.com. In this video, we will look at how to put an IPSec VPN connection into VRF, both for traditional crypto map and VTI. So for those of you who's not too familiar with VRF, VRF stands for Virtual Routing and Forwarding, and basically what VRF allows you to do is to create multiple routing table on a single hardware. So what happens when you combine VRF with VPN? You can, for example, if you have an extranet or partner VPN connections that you want to terminate on the same physical device and still have them logically separated for security, you can put each of the VPN into its own VRF, and that way you can protect each tunnel from one another. Another application for this is for a service provider that wants to bring a client remote sites into a MPLS cloud, for example, but the site just happens to only have internet connectivity. So what you can do is to build an IPSec VPN connection and then place them in its own VRF on the head-end routers, and that way all the traffic can be placed into its corresponding VRF and then into the MPLS. So you can see the two can create quite a powerful combination. Okay, so let's take a look at the topologies that we have for this lab. We have two routers, R1 and R2, R1 being a head-end router that has the back-end LAN interface that's part of the VRF HQ, while the R2 is going to be the router on the client side, and we're going to build IPSec from R2 to R1. Okay, so first we're going to start our configuration on the router R1. And you can see the majority of the config. We're going to start with the crypto map, traditional crypto map first, and you can see the majority of the config will be very similar to what you've seen, with a slight modification which you will see to support the VRF. And here's to show you we have the interface and the LAN interface, which is FAS00. It's part of VRF, and the command for that is IP VRF forwarding HQ. You can also do show IP VRF, and that tells you we have one VRF called HQ and has a interface FAS00 as a member. Okay, so if we do ping VRF HQ, and if we want to ping like a backend switch IP, which is 192.168.2.1, okay, you can see we can ping successfully. So let's start our config, as always, with any other IPSec site-to-site VPN. We probably want to start off with the crypto ACL. So we're going to call VPN_site. That's going to permit IP of the subnet on the right, which is VLAN 32, to the IP subnet. It was the subnet on the left, rather, to the IP subnet on the right, which is 192.16.128.0. Next, we're going to have to create a crypto keyring. We're going to call it site. And here is where we define our pre-share key with the address of 222.10, which is the address of the R2 interface, with key called Cisco, or key Cisco. Next, we create an ISACAM policy. As always, for phase 1, AES256, authentication, pre-share key, group 5, hash SHA, leave a default lifetime, then crypto ISACAM keep alive, interval 10 seconds with retry of 3. Okay, next we're going to create a crypto ISACAM profile. We're going to call it LAN to LAN ISACAM profile. And under that, we're going to say this particular profile belongs to VRF HQ. So in the tunnel that's built to this or match this particular IPSec profile will be placed into the VRF HQ. Next, we will configure the keyring that we defined earlier called site. We're going to be matching by identity address, assuming the RSI uses the static IP 2221.10. You can redo the keep alive also if you want to override the global. Okay, so you can see so far it looks like you need to create a keyring and an ISCAN profile for each of your connections. So if you have a different connections for different VRF, then you'll create multiple of these. Next, we'll do the phase 2, which is crypto IPSec transform set called ESP-AES256. SHA with ESP-AES256, and then ESP SHA HMAC. Next, we'll create our crypto map called VPN map sequence 10. I want to use ISCAN for key exchange instead of manual. And here, first we do our match address. This is a crypto ACL that we created called VPN_site. Next, we'll set peer 222.10. We'll set security association lifetime 1024,000 kilobytes, and then we do second 800. So we need lifetime. There you go. Then we set transform set. And the one that we created is called ESP-AES256 SHA. And we also need to tie the crypto map to the ISCAN profile called L2L IPSec profile. Okay, next we set PFS group 5. Okay, let's see what else we can do. You can also do a reverse route, and it's always not a bad idea to do QoS pre-classify. Okay. And to finish up the config, we do interface fast 0 on the outside and tie the crypto map to that. Okay. So let me get the ping going before I jump into the configuration of router 2. So I want to ping from the PC on the right here with the IP.32. I want to ping .16.32.1. So have that going. Okay, so the configuration differences is only on the head-end router where you define all the VRF. As far as R2 is concerned, there's nothing it needs to change from any regular IPSec VPN configuration. So what I did, I have created a template already from the client side just to save us some times. Right here, because you can see it looks identical to the scenario where you don't use VRF at the head end. So we're just going to go through that real quick. You got crypto ACL, define, keyring, with the phase 1 ISCAN policy that matched the head end with the keep alive. We also do the profile, ISCAN profile, but without the VRF option, since we're not doing VRF on the R2 client side. And then you have the IPSec transform set phase 2. I believe we didn't do the DF bit clear, so let me remove that. Phase 2 is pretty much identical. So let me go ahead and copy that, paste into R2. Okay, and we start to have pings replies. Okay, so if you do on the R1, our head-end site, Crypto ISACAM SA, we got our QM idle. If you do detail, you can see right here, IVRF. It tells you the particular VPN tunnel is associated to VRF HQ. Just to show phase 2, since we're able to ping, you can see NCAP, DCAP packets, and we are good to go. So let's do show run real quick. So the main difference is you need to specify you need to specify which VRF you want to put the VPN connection into under the ISACAM profile. Other than that, it's pretty much the basic VPN configuration. Okay, so that's for the traditional crypto map. The next thing we're gonna look at is the VTI, or virtual tunnel interface. So let's turn our configuration on R1 into VTI. So first we need to remove crypto map from the interface, as well as the crypto map configuration in general. Okay, instead of doing crypto map, we're going to do crypto IPSec profile, LAN to LAN, call it LAN to LAN IPSec profile. And let's see if we can copy some of these. We can do set security association. We don't do peer because that's going to be specified under the tunnel destination. We can do transform set. We still need to tie it to the ISACAM, and we can do set PFS group 5. We do not do match because we no longer use crypto ACL for VTI, but instead we're going to use routing to put traffic into the tunnel. Okay, so we paste all those in, and then we move to a tunnel interface configuration. Let's give it an IP address. Okay, 192.168.0.1, 255.255.255.252. The QS preclassifier has been moved to the tunnel interface. And then we have the tunnel source configuration, sourcing fast 01, which is our outside interface. And we have to turn this into mode IPSec IPv4 because by default it's GRE. Then we do tunnel destination 222.10, and we have to tie the IPSec profile to the tunnel interface. So here, okay, so one thing that we also need to do is to remove the VRF HQ under the ISACAM profile, because now that VRF configuration has been moved with VTI configuration to the tunnel 1 that we did. Let's see. So if I go ahead and remove that, let's make sure we have a tunnel interface configured correctly. Looks like we're missing out on the IP forwarding, so let me do that right now. IP VRF forwarding is a very important command to place the tunnel into the VRF HQ, and as soon as you do that, it tells you they will remove any existing IP address, so we need to put that back in. Okay, now that we have that, we should be good to go. One final thing, to force the traffic into the tunnel, we need to specify a static route, unless you want to use the routing protocol 16.128.0, which is the remote site subnet, and we put that into tunnel 1. We can verify that doing show IP route VRF HQ static. Okay, right here. Okay, so now let's make the similar modification to R2. First thing you need to do is know crypto map VPN map. And no crypto VPN map 10. Okay, and we can pretty much copy over what we have on R1. So let's see right here. We can copy that just to make sure that matching. And for the tunnel interface as well. Let's remove the VRF forwarding command, update the IPs, update the destination IP, and put that for router 2. And we also need an IP route 172.16.32.0, 255.255.255.0, tunnel 1. Okay, you can see as soon as you do that, we got our ping back. Got a QMIDL. QMIDL again, if you do details, the one that's active is placed under VRF HQ again. And our phase 2 is also up. Okay, so that's the config for the static VTI. With the share outside interface, just need to want to point that out. So for this scenario, if you want to share an outside interface for multiple VPN connections that are going to be placed under different VRF, this is basically what you need. Okay, let me do show run, pipe begin, IPSec. Okay, you can see right here when we did the no VRF HQ, it got automatically placed under VRF Global, which is the default. That just tells you that the front end interface or the outside interface is part of the global routing table since it's going to be shared. Okay, and the only VRF specific commands that you need to put is now moved to the tunnel 1 interface, which is IP VRF forwarding. Okay, so that is for the static VRF with the share outside interface. The next scenario that we're gonna configure is for the dedicated outside interface. So for whatever reason, you need to dedicate a physical interface just for that one VPN or one VRF. Then here's what you need. So back on R1 configuration. Right now, if you look at FAST01, which is our outside or front end interface, it's on the global routing table. So what we need to do, we need to put that under HQ. And since the IP is now removed again, I have to put that back in. Okay, next we need to make sure R1 knows how to get to R2 using a VRF routing table under VRF HQ. So we need to do IP route VRF HQ 222.10 255.255.255.255, and the gateway is right here 1111. Okay, and it's to check the connectivity between R1 and R2. Okay, now we can ping from R1 to ping R2 222.10. Okay, the next change we have to make, but we're just gonna, it's the key ring, but we're just gonna go ahead and create a brand new crypto key ring. This time I'm going to call it site VRF, and here there's an option that we didn't do earlier since we put that in the global routing, the front end interface, or the share interface. But here we need an option VRF HQ. So we tell the router to use this particular keyring for the VRF HQ. And the pre-share key part is pretty much the same. Okay, now we get under the crypto IPSec profile. Let's see if I can just copy and paste from what we have up here. Okay, we're going to put this back before it said VRF Global. We're going to put this back under VRF HQ. And let's do this so we can see what we have right now. We're going to update our keyring. So now keyring is going to become site VRF, which is the new one we created. And for the match identity address, we need to delete that and make sure we specify the F or the front VRF. You can see here default is global, but now that we have turned our outside interface to be part of the VRF HQ, we need to tell it this IP is now reachable by the VRF HQ. Okay, and the last thing you need to do is under the tunnel interface, and the command is tunnel VRF HQ. And the reason that you need this command is to basically tell the router that the tunnel destination IP 222.10 is now reachable through the routing table under VRF HQ. So as you can see, as soon as we did that, we got our ping back, and that's pretty much all the config that you need when you have a scenario with the dedicated outside interface for a VRF. And here the connection from the router 2 came back automatically, so as far as the router 2 is concerned, it doesn't even know that there is a configuration change on R1. So it's totally transparent to the client side. So as you can see with 3 different scenarios, crypto map, VTI with share interface, outside interface, and VTI with dedicated outside interface, you can see that there are different places that you have to specify the VRF option. So you just need to know to specify the VRF at the right place, otherwise your configuration may not work. Just to recap for the dedicated interface to show you, first we need to specify, I guess this keyring is not in there, so let me start with keyring. First you need to specify the VRF that ties to the keyring, then you have to specify the VRF that ties to the IPSec profile, then under the tunnel interface you have to make sure you put VRF forwarding as well as the tunnel VRF. Okay, and then finally the outside interface needs to be tied to that one VRF as well. Okay, so that basically completes our configuration on VRF with IPSec VPN. Thank you for watching LabMinutes.com. I'll see you guys in the next video.